Alright, the XOR gate, or the exclusive OR gate. This is where it gets complicated, so bear with me and pay attention. We've got a 3 by 2 block here, so, and we're going to build a T shape on the top. We're then going to cut out this block in the middle. We're going to take our torches. These torches here have to be on top of the block, like so. There and there. And these torches, these three, have to be on the side. Here, here, and here. Very important you get that the right way around. Then we're going to put redstone here, here, and here, and here. And then we're going to run in our inputs here, and here. So take our levers like so. I'll just run the output out here so we can see what we're doing. Now, the output is only on if the inputs are different. If I turn this on here, the output turns on. But if they're now both on, the output turns off again. It's the other way around. So this output is off and this output is on. Turns back on again. And again, if they're both off, nothing happens. So the output is only on if the inputs are different. Alright, what I've built here is an exploded view of this gate we built over here. So both these inputs here first run into NOT gates. So those NOT gates can be seen here, this block here and this block here with the torch on the top. So these here are the outputs here, but they also output into these blocks up here, which run this redstone here. That redstone there would be the equivalent of this piece of redstone here. Okay, so these NOT gates run into two different gates. They both power this NOR gate here, which is this NOR gate here. And they also power two NOR gates. This NOR gate here is this NOR gate here, which you can see directly runs like so from the output of the NOT gate. This NOR gate here is powered directly by the output of this NOT gate here, and then the output of these two NOR gates run into here. These NOR gates are also powered from this NOR gate here, which is this NOR gate here, which is powered like so by powering these blocks here, which in turn power this redstone here. So if I were to turn both these outputs on, this redstone is no longer powered because neither of these blocks are powered. So that's how it relates. If we now look at the exploded view, we can actually, because this gate detects whether the outputs are different, whether these outputs are inverted or not is irrelevant. So I'm just going to quickly get rid of this. Just put levers in like that to make it slightly simpler. Alright, let's take a look at the exploded view of the gate now. 3 NOR gates, one here, and one here. These two NOR gates are symmetrical, but the same on either, the same on either side. So what I'll just quickly do is have a look at this side. It holds the same for this side. This NOR gate here powers this NOR gate here. Right. So when this input turns on, this NOR gate becomes unpowered, like so. There's no longer an input here, but this NOR gate is now powered by this lever here. So it stays off. So if this lever is off, this NOR gate cannot be powered. Doesn't matter what you do. There's always going to be something powering it. But if we look at the other side, this NOR gate isn't powered by this lever at all. This lever is always off. So now when we flip this switch, all that's happening is this input to the NOR gate here is being toggled, like so. Which in turn allows this NOR gate to turn on and off. So doing the output of the gate. This is why the gate only provides an output if the two inputs are different. This switch is now allowed to toggle the output, but only if this switch is on. If we turn this switch off, toggling this switch has the same effect as toggling that switch did on the other side. It only toggles this input to this gate here. So this NOR gate is always going to be off regardless of what you do. If you're toggling this switch, because you're swapping between this input. But what you're also doing is toggling this input to this NOR gate here, which allows you to toggle the output like so. If they're both off, both of these NOR gates are powered by this NOR gate here, no output. If they're both on, both of the NOR gates are toggled by their respective inputs, so no output. It's only when they're different, turning this NOR gate off, that an output can be turned on. Alright, in terms of constructions, there's really not many places you can go with this. The problem is that these inputs both have to go into this gate and into a separate gate, and the output of this gate also has to go into these. So this construction here is about as compact as you're going to get it. If you're working with tight spaces, what you can do is sort of try and extend it out a long way and actually have these physical wirings between the gates separated by layers like so. And then you can run redstone here and above here. But that's very, very specific depending on what kind of space you have available. So really, if you want to use this gate, you're going to have to use this construction. You can flatten it. Actually, I'll be right back with a design for that. Alright, sorry about that. Wasn't expecting to have to do this, but here we go. This is about as compact as you can get it if it's only one tool. So if you say you need to fit it in under a floor or between a ceiling and a floor. So if we take our two inputs here, gates on, as you can see the outputs here, they're no longer different. Output turns off. You've got your NOR, you've got the same pair of inverters here and here, the NOR gate here, and these are the NOR gates here. So it runs through that. If you think about it, you can kind of figure out where it goes. So yeah, that's if you want it flat. There's really no way of getting it tall and thin, as I said, due to the complexity of this here, with the gates having multiple inputs, and in fact the inputs running in between gates inside the circuit itself. So like I said, this is as compact as it's going to get. This is what, 3 by 3 by 3, so that's a square of 9 there, not counting the inputs and the outputs, of course. Well, you can count the outputs here. So that's 9 by 9 there. So yeah, that's alternative constructions. Alright, uses. I built another demonstration here. I am fond of my demonstrations. I'm sure you've all seen these systems in sort of real life. These are most useful when you need two sort of steady state inputs, such as levers, both to be able to toggle the same machine. So here I've set up some lighting and plugged it into the output of the X NOR gate here, and just link them all up. So we're going to toggle this switch here. Oh, that's twice. And the lights turn on. But we've now reached the end of the corridor, and we want our lights to be able to turn off again. So we toggle this switch here, and they turn off because the outputs are now the same. But say someone else is coming in this corridor here, they can now toggle this switch, and the lights turn on again because the outputs are different. Or if someone's coming in from this end of the corridor, they can also toggle this switch. So the upshot is that either switch can always toggle the machine, regardless of the state of the other switch, which is quite nifty. Other than that, again, like all the logic gates I've shown you so far, they tend to be used in more complicated redstone circuits if you're setting up a decision machine of some kind or description. So yeah, XOR gates, simple really.